Good morning, Bears. Is it Wednesday already? Wow. I think it is. Elle is on campus today, Wednesday. The people that are here today will come back on Friday. Remember, breakout rooms, like the real kind, where you break out of your room and come visit me. Totally cool. Just keep your mask on, 6 feet distance. So if you're in my class on Zoom and you're on campus, ask your teacher if you can go check in with Mr. Downs live. Break out of your room, come by, we'll say hi. You can look onto the Zoom that we're teaching, get a quick tour of the room, especially if you haven't done it yet, and just get yourself some movement. You want to do that during our work time, during the beginning of class, end of class, when we're in other breakout rooms, not when you're watching a video and will miss anything. And you can always tell me you're on your way, but I wanted to remind you that breakout rooms, the new version. All right, let's do this. So we're in courses. Remember, it's a science week. Go back and turn in your history in this first 5 minutes of class if you've forgotten. Look at here. Louis turned in his. Antonio's catching up. Sebastian A's turned in Intro to India. When I see you turn something in here, I click it and I go grade it. If you don't submit it, I don't grade it. So if you're missing a grade, that's because you have not submitted. SUB-MIT, submit. Today we're in a science week. Click science. Make sure you're in courses, you're in science. You look to the right, you see intro climate change. You click it. You click my document, you click edit, and then you will be in the category of in progress right here. I'm going to look at somebody from 2 quite a bit now because of the time of day I do the lesson. Jens, why have you not opened up your slideshow? Come on, kid. So I looked at Kareel's, I've looked at Emma's. Let's look at somebody else that I think. Dayanara, usually, is she on track? We'll see. She's on track. Looks like she is on track. Fantastic. Thank you, Dayanara. So let's look at Dayanara's slide today as a little example. So this is Wednesday morning. This is what your slideshow should look like as of a Wednesday morning. I think it's always a good idea to put your name. So it's pretty easy to do that. I don't know why that's doing this here, to be honest with you. What's going on here? Anyway, it's not letting me change it. But you can always delete that. Weird. Oh, there it goes. So I was just in the wrong place. So I put by Dayanara. I recommend don't put in your last name just because these might show up on YouTube. All right. So Earth's Changing Climate by Dayanara. You should have your title with your name on it. Maybe you put your own words, your own pictures. It shows me you care when you do a good title. Then top slide. The last thing we ever do should be top slide. So what's the last thing we did? Dayanara, you're a rock star. She took this slide. This was around slide 22. She modified it. She put her picture there. These are the questions. What information is provided on graph A? A lot of summer sea ice in graph A. Yes. Does that fit? Yes. What can you conclude about the amount of summer sea ice in the Arctic based on graph A? Over 6 million summer sea ice. Where does she get that? Look here, 6 million over the top. So over 6 million, yes. 3, what information is provided by graph B? There's a lot of summer sea ice, but it's going down. It's going down. Graph B, it's showing it trending down. She answers it. 4, what can you conclude about the amount of summer sea ice in the Arctic based on graph B? It was trend, but something has happened to decrease it. Yes, the trend was going pretty stable. Something is happening to decrease it. Remember, the bottom is time. Up tells you what? Millions of layers or kilometers of sea ice. This is also time. So these 2 horizontal axes are the same information. Notice the bottom, though, is 2002 to 2014. And this is 1880, so way bigger gap. So what you could do is 2000 to 2014 is right in this area. And they're showing that here. So what you're comparing is what's happening here that might confuse them. Well, all of a sudden, this last line is going up. So if you just looked at this, you'd think, oh, it's starting to go up again. But if you look here, there's an up here, but then it goes back way down. So the trend is still down, even though there's spikes here or there. That's the point. Why do you think some scientists initially disagreed about the overall ice distribution? I'm not sure, but that much ice wouldn't just decrease in just a few, so maybe that's why they disagreed. Great thoughts, Dayanara, but here's the real reason. Look what's happening in this graph. The last line, it's going up. So they're thinking, no, it's not decreasing anymore, it's going up. But if you look at this one going to 220, it shows the up, and then it comes back down. That's why you need, when you're looking at data, you need to look at the big picture. So you should have something like this, top slide, and then temperature was a new concept that we added on Tuesday. Energy, new concept we added on Tuesday. We know about these, the ability to make things move or change. Temperature we know about from our other studies. Trend we already should have had. Fluctuation we should have. Climate we should have. And climate change. Now, these are the entire concepts, I think, that we have done. I'm going to just move the screen over to show you. Notice in her, over here to the left, you can see what her slideshow looks like. Yours should look like that if you're on track for an A. Good job, Dayanara. Let's get going on today's lesson. In yesterday's lesson, we're going to now investigate this question. What could be causing ice to melt and temperatures to increase on Earth? So ice is melting and temperatures are increasing. What do we think that is? Let's dive into our sims. In this lesson, you will use Earth's changing climate simulation or watch a video of the sim. We'll do both. Check with your teacher. I'll tell you how to do that. This is the Earth's changing climate sim. It is similar to the apps used by scientists who study climate change. You'll watch a video to get familiar with the parts of the sim. Now remember, guys, I will play with this. We're going to watch this video. I will play with the sim in the video. Everything you need from this video or my video playing with the sim is enough to do the day's activities. But if you really want to challenge yourself and you really want to learn, you want to dive into the sim, I will provide you the link in groups and play with the sim. All right, let's do this.
This is the Earth's changing climate simulation. You'll use this model to investigate changes to the Earth system. Let's review some of the important visual representations in the sim. Outer space is separated from the atmosphere by a dotted line. These yellow arrows represent energy traveling into and out of Earth's atmosphere. Let's run the sim to further explore its features. The yellow circles show energy being absorbed or taken in. You can see that here at the surface. The amount of energy absorbed by Earth's surface is represented by a yellow glow. As the amount of energy absorbed increases, the glow gets brighter. The white area represents ice on Earth's surface. The amount of ice on the surface can increase, decrease, or stay the same. The panel on the right has things you can change: the amount of sunlight, the amounts of different gases in the atmosphere, and how reflective the surface of Earth is. At the top left, you can see data about the sim test. These numbers tell you how much time has passed, the average temperature, and the amounts of energy that have entered and exited the Earth system. You can further analyze data by pressing the graph icon. If you want to start over, use the reset button in the top right corner. The Earth's changing climate sim is a useful model that will help you explore various aspects of the Earth system.
Cool. I like the sims. Did it pause? Yes, it did. All right, good. Now, get out of there. Cool. So you have this video. There's another link to the video, and let's dive into the sim. Energy travels from the sun to the Earth and is absorbed by the Earth's surface. We know this. This energy is transferred to the air just above the surface, affecting the temperature. This sim does not show details about how the surface warms the air just above it, but looking at the temperature will give us evidence of when the energy is transferred to the air. So it's not showing the energy moving from the surface to the air, but if the temperature is going up in the air, we know that energy is coming from the surface. Your first mission is to make ice melt in the sim. Since energy and temperature are connected, you'll need to pay close attention to the energy in this mission. Since energy and temperature are connected, you'll need to pay close attention to energy in this mission. I just wanted to repeat that. Resetting the sim will ensure you start out with enough ice to melt. The starting image will give you a baseline before you begin the mission. Awesome. Go to the Making Ice Melt in the Sim activity. Use the sim or watch a video of the investigation. All right, here we go. I'm going to play with the sim, but I really want you guys to play with the sim. But if you're at home and the sim doesn't work, whatever, you can just use my sim to answer these questions. And we'll look at that here. We're in the sim here. Let's get this baby rolling. Let's always make sure it's reset. So look, nothing's happening here. We haven't hit play. We've got our sunlight. Take a screenshot of this. You can take a screenshot of this right now in the video or go play with the sim. In the reset button, take a screenshot because you're going to put that in your top slide. Do that now. Take your screenshot. I'm going to give you 5 seconds. Go open the sim. Log in. Find it. Reset it. Take a screenshot. I'm going to give about 10 more seconds. Just screenshot it. If you did not do that, you can do it later or come back and watch this video. Now, what do we want to do? We want to melt the ice. Let's click play. First, look what's happening. We have outer space. We have the atmosphere. I don't see any ricocheting off that I can see. Now, remember, we've got the surface. This is ice. This is the surface. And there's like a glow, and that glow should change. Let's see, energy entered. Those are totally matching right now. Global average temperature 14.6 and our time. So first thing I want to do is I want to crank up some sun if I'm going to melt the ice. Okay, temperature's going up. Interesting. Look at the energy entered is a lot more than the energy. Oh, look at that, sun's gone already. Wow, pretty quick. That's awesome. Let me see what happens if we go no sun. I want to see what happens here, just for fun. We're playing around. Does ice come back? Ice is coming back. Now, let's look at our temp, 15. Oh, look at that. Energy exiting is way more than energy. Oh my gosh, we're going into an ice age. Now we better bring the sun back. What if we did low sun? And then you can check your numbers. Let's bring up our carbon dioxide, methane. Only mutants can live here, but I'm just having some fun. Reflectivity. I'm going to go high just for fun. Oh, look, the sun's leaving. And I didn't raise my sun at all, and the snow's leaving. So raising the sun, and then check our temps again. Temps going up. Crank it. That's interesting. Okay, snow's going back. Temps going up. Energy entered, energy exited. It's going back to kind of similar the same. So that's kind of interesting. Do we see any bouncing? I don't really see any bouncing. All right, so get that. Oh, look, it stayed. It's kind of stabilized. Let's bring the carbon dioxide down. Methane down. Dioxide down, nitrogen dioxide down. Oh, look at this. Sun lights up, ice is coming back. Wow, that's kind of crazy. I'm going to move these around again. What's going on here? I'm going to try my reflectivity low. I did it the first time. All right, now, ice is leaving, and pause. Once you get the ice to go back small, take another screenshot. Play with that now. Do another screenshot. You can do it now. You can do it later. Get it done. So you're going to have 2 screenshots in your top slide. 2 screenshots in your top slide. All right, let's get back to Dayanara's slideshow. Now, Dayanara, I actually put the directions in here for you, but I'm going to put these into groups. So these right here are the basics for the day. What do? Watch the video lesson that we just did. Create new top slide. We're going to do that. Open sim, take screenshot before adding energy, and then we're going to put, oh, here it is. Find a way to make ice melt. Take another screenshot. Add both screenshots to top slide and explain why the ice melted. What was going on? I just walked you through it. You can do it with this video. Better if you play with the sim on your own. Average temperature. That's like a question mark, right? So what were your average temperature? What happened to the temperature? Did the temperature go up and down? You might explain that. What about energy absorbed by the surface? More reflective means less energy into the surface, probably less energy to the air. When my video, you saw what happened. What about the total energy on the Earth? Any one of those. You don't have to do them all. Now, this will also give you ideas. This little box here, you don't have to answer these questions. You just do this. But this gives you ideas if you want to think about it. And if you're really confused, you move down and say, what could be causing ice to melt and temperatures to increase? Earth. That question is going to be answered here. We'll start on that tomorrow. But usually, you might have figured out by now, if you go down a little bit, next couple slides, you will get some clues on how to answer this question. All right, what's the bottom line? Play with the sim. Understand what's happening. Why does ice melt? Because that's what we're trying to find out. All right, let's do this. Thanks, Diana. Great slideshow. All the information is in groups. Out.